Chapter 2, Design Tools, Part 1 of 2. Questions that we'll answer in this video. What brainstorming techniques do engineers use to generate ideas during a design process? What kinds of sketches do engineers use to develop their solutions? And what kinds of computer-based modeling methods do engineers use to develop their solutions? And how and why do engineers use analytical tools? Design process. A design process can be thought of as a systematic problem-solving method for generating and developing ideas into solutions. Problem solving is not always carried out in a linear fashion. Design process, Step 1, define the problem. Analyze a less than ideal situation, figure out the root of the problem, and clearly define that problem in a concise manner. The ability to do those things is of great value because the problem may be presented in such a way that requires refinement through careful and thoughtful listening, questioning, and interpretation. A design brief is a concise information tool that summarizes the most important information about a design project. The information contained in a design brief will identify the person or entity who serves as the client, the individual or group who will be held accountable for the design service, the client's problem, need, or want. The challenge will result in an engineering solution and the degree to which the solution solves the problem, and any limitations within which the engineer must operate throughout the design process. The problem statement is written to clearly and concisely identify a client's or target consumer's problem, want, or need. A design statement challenges the engineer to take action to solve the problem. There are no industrial standards associated with the format of the design brief. Design process, Step 2, brainstorm. A design team will conduct a meeting of minds to openly discuss the problem, identify existing knowledge that team members have that relates to the problem, generate questions that need to be answered, and define areas of focus that will be assigned to various members of the team for research. Brainstorming is often repeated during the other steps of the design process. Ideas are not evaluated or judged at this point. Design process, Step 3, research and generate ideas. One of the qualities of a successful engineer are an insatiable passion for knowledge and an understanding of the critical role that research plays in development of creative solutions. It is the responsibility of the team members to fan out and search for answers. There are two kinds of research. Primary research involves generating original information through interviews, surveys, experiments, and observations. Secondary research is when you do a keyword search on a website to look at previous information. The engineer's notebook is a place for recording important book titles, useful website URL addresses, and the names and contact information of people who have expert knowledge about topics that relate to the problem. Research is something that an engineer will perform multiple times throughout a design process. Having a set time for all group members to come together and share their information is important. Deadlines for initial research will drag on at the expense of the entire project. Having an engineer's notebook handy not only allows designers to recall important information accurately to their team members, but also gives them a place to jot down sketches and ideas that occur as teammates share their knowledge. Design process, Step 4, identify criteria and constraints. Having researched the problem and developed a clear understanding of the challenge, the team and the client will come together once again to identify and agree on limits within an acceptable solution must be developed. These limits will be added to the design brief as a list of criteria and constraints. A criteria is a group of specific standards against which a design will be judged acceptable or unacceptable. Constraints are a general limit that is imposed on a design project, such as a project deadline, a budget, materials, or manufacturing processes. Design process, Step 5, explore possibilities. Exploring possibilities involves returning to the initial solution ideas and sketches that were recorded in the engineer's notebook during brainstorming and research and generating ideas and building from them. Members of a group will listen to the ideas expressed and expand on them, combine them, and sometimes twist them into completely unexpected directions. Team members are then given the task of identifying 2 or 3 ideas that they believe have the greatest potential, recognizing the limitations that were set forth during the criteria and constraints. The team members will generate more sketches and might even develop CAD models if the designers are proficient and have enough time to do so. The team and sometimes the client will meet to conduct a formal critique of the detailed ideas. Design process, step 6, select an approach. The answer is often based on trade-offs that the client or designer is willing to make between a solution's functional, structural, aesthetic, economic, and environmental qualities. Engineers and designers need to make sure that they do not develop an emotional attachment to an idea, as it can ultimately lead to the demise of a project. Two ways to prevent this from happening. 1. Give the client the responsibility for selecting an idea, and 2. Use a tool called a decision matrix to help the team come to a consensus on one idea. Here's a decision matrix. Decision matrix, a chart that designers use to quantify their opinions of two or more design ideas by assessing each idea according to a series of important considerations. Just as an example here, it has the objective down the side, different things like generating new ideas, networking connections, deepen existing connections, customer feedback, improve website search engine results, increased visibility, developing authority, and online sales. So then what you do is, on a scale of 1 to 10, you rank how a website would do at generating new ideas. And then you go down each of the objectives, and then you get a total for each one. The one with the highest number would then be maybe the best idea, or the one that people like the best. So in this case, it would be a website because it has a total of 44. Two numbers may be used, one variable and one binary. The variable scale can include any range of numbers that is more than 2. The totals from each team member's decision matrix are then averaged to determine which idea received the highest score according to the group. This kind of technique helps to ensure that important decisions are not made as a result of individual pride or emotional attachment to one idea. Design process, step 7, develop a design proposal. A design proposal usually consists of CAD part models and assemblies, assembly drawings, and dimension multi-view drawings of each manufactured component. The goal of a design proposal is to document the solution to the degree that a competent manufacturer could build a prototype without the need for further clarification on the part of the design team. Design process, step 8, model or prototype. Before a solution is turned over to the client, it should be tested under controlled and actual working conditions. A prototype is a one-of-a-kind working model of a solution that is developed for testing purposes. Design process, step 9, test and evaluate. Testing may include applying forces to structural components or an entire assembly to ensure that the design can withstand the loads to which it will be subjected. Data must be recorded, organized, and analyzed. This step in the process includes tests that measure a solution's functionality. Design process, step 10, refine. All ideas for changes to the design should be sketched out in an engineer's notebook and accompanied by explanations that identify why the changes are necessary. It may also be necessary to update the existing CAD models and technical drawings. Design process, step 11, create the final solution. The design statement contained in the design brief will identify whether the final solution is to be a custom design, a limited production item, or a mass-produced item. Designs that involve mass production often require additional efforts from other professionals such as manufacturing engineers, systems engineers, and tool and die makers. Brainstorming ideas. Brainstorming allows team members to think creatively without judgment or constraints. Participants should neither feel embarrassed to share their ideas nor pressured to conform to the expectations of others. Group versus individual brainstorming. Individual brainstorming can yield better ideas because 100% of the participants' attention is focused on generating ideas without the distraction of listening to other people. Group brainstorming takes advantage of a wider experience that the diverse members of a group provide. Group brainstorming is a great way to demonstrate that everyone has something to offer, and it helps everyone feel involved in defining the end solution. Guidelines for traditional group brainstorming session. The group is seated around a large table so that participants can see each other. Group efforts often require the guidance of a facilitator. This person may participate, but is also responsible for directing the session, keeping the group focused and encouraging the quieter members to participate. Guidelines to follow. Stay focused on the task at hand. Do not judge or criticize ideas, but feel free to ask questions and provide positive comments. Don't limit yourself to only rational ideas. Build off the ideas of the other participants, and only one person should present their idea at a time. When someone has an idea, they should hold up a sketch for everyone to see, explain it, and affix it to a large wall that serves as a collection point for the ideas. Be polite and wait your turn to talk. Brainstorming is supposed to be engaging and fun. Other methods of brainstorming. Stepladder method. Clearly define the problem and the criteria. Allow group members time to create ideas individually. Two group members come together to share their ideas and brainstorm new ideas that develop as a result of the sharing process. A third member is added, who presents their ideas to the other two members, then listens to the ideas from the original two members. After all the ideas have been shared, time is allowed to brainstorm new ideas. Repeat the previous step by adding one new group member at a time until all members have joined and shared their ideas. Reverse brainstorming. The reverse brainstorming process focuses on the cause of the problem. Reverse brainstorming is a good method to use when a problem statement is very broad. Clearly define the problem. Reverse the problem by stating it in the form of a question. Generate ideas to answer the question, and generate ideas to alleviate the causes of the problem. Wrapping up a brainstorming session. Start by eliminating duplicate ideas. Give everyone time to study and understand all the ideas. Ask each member to identify their 3 favorite ideas by placing a small post-it note on the sketch. Tally the votes to determine the top choice. That ends part 1.